Okay, do you want to go through and show everything that's already...
Ooh!
Biggie. I got a few minutes, yeah.
I got me drink.
Yeah.
Ahoy, 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 we are live, as you can tell, because I just received my can of soda. Welcome back. UPS guy just arrived. That's the guy that picks up all your packages and ships them all out to you.
Why did all three of you look up?
Because you know something, we are princesses.
I just wanted to, you know.
But the thing
That's the UPS guy.
Prince, man.
Where is he?
Hey,
Let's see if I can.
Yeah, you did.
But you don't seem to complain.
See, look, there's our UPS guy right there. There he
Hi,
is.
everybody. What did I say? You still can't see me?
No.
He keeps moving.
Yeah.
Where are you?
There,
Yeah, there you're behind the light.
Where's
PL.
Fruity Dan?
Fruity Dan somewhere. So what are we talking about today? Today we are going to be talking about the Starlight Xpress camera. We have a couple of selections, and obviously we actually have a special that we're running right now, which is like 15% off on select cameras. So we're going to go through those first. I have here with me, this particular one is the CoStar, the Starlight Xpress CoStar Focus. Come on, it's thinking, and well, good enough. So there it is right there. It's a small, little tiny camera. You know, there's a little CCD in there. Why are we doing a special, or what is the point of looking at these cameras? Their big thing is doing guiding. A lot of you who are doing long exposure photography normally will have some kind of a guide scope or an off-axis guider, and the idea here is UPS guy is delivering your packages right as we speak. So yeah, what was I saying? Oh yeah, guide cameras. So the idea here is when you're doing any type of guiding, you need a camera that is sensitive enough to pick up on some of the stars that are in the field. Now, majority of people who tend to use Starlight Xpress products, especially their guide cameras, namely the Lodestar X2 and the Ultrastar, you need something very, very sensitive, because the chances are you're doing off-axis guiding. The off-axis guiding is, just imagine a small little pick-off mirror that picks off a portion of the light and then sends it to the camera, and the camera then goes into PhD and it does all the guiding. Well, the problem here is if you buy some of the more inexpensive units in the market, depending on who the company is, they work great if you have fast optics. So the idea here is you kind of want a camera that is incredibly sensitive. Now, how Starlight Xpress does their cameras is they opt for large pixel sizes. Sorry about the focus, because this is on my phone. So the one that we're talking about first of all is a Lodestar X2. Now X2 does not mean 2 times Barlow or 2 times power. It's just version 2 of the Lodestar. The original Lodestar, where it differs is on the back. It has the RJ12 6-pin 6 connector plug, whereas the original one had this 6-pin thing that you kind of plugged in, and the biggest complaint was it broke a lot of the time. So that was kind of a frustrating thing for them. So they updated the design and they adopted the RJ12 connector just like everybody else does. So that's how that kind of was devised. More importantly though, the sensor has been upgraded. It actually uses the Sony ICX829. It has a 8.6 by 8.3 micron. It's not a square pixel. So what happens here is when you actually use the camera, when you're doing the guiding part of it, you end up with this oblong shape, for a lack of a better description. There is a function that squeezes it back down into a 4:3 ratio, supposedly. It's not true 4:3, but the idea behind that is it gives you more vertical resolution, which actually gives you a better resolution image. Now, granted, the actual pixel size being so big, but the actual sensor being so small on top of that, it's only a 0.44 megapixel system. Give me 1 second. Hello?
Hi, I had called you about the T7i
Yes.
bundle.
Give us 2 seconds, everybody. I know we're actually live on the store here, but there's the customer here. It's okay. We're doing stuff live. Dave, It's all set up over there by the counter
Perfect. Thank you so much for having me.
as a T7i. And where are you going? You're going to Chile, right?
Going to the observatories in Chile.
Exactly. So this lady here is going to the observatory in Chile. She chose to do the T7i. For all you people out there that were just curious, you know, we really do sell astronomy equipment. People really do come in here and buy this stuff. The tripod is $79.99, and it's the smaller one that does not disassemble and all that stuff, but it's going to be perfect for you to take on the plane.
Perfect. I have a backpack, so I can just grab it too.
Excellent. Anyway, sorry about that, ladies and gentlemen. We will reserve questions for a little bit later on in the program. Anyway, going back to the Lodestar and the Ultrastar. So the Ultrastar, on the other hand, is a slightly different camera. Its actual forte was kind of developed to do deep sky. A lot of people actually like to use it for planetary nebulas. Again, it's actually got quite a big pixel size, 6 point something odd micron, 6.5 we'll just say, give or take a few, which is actually quite big. And it's near HD video size, so 1300 by 10 something, 1020, 1080-ish. That's basically almost 3 times the size of the Lodestar. Whereas the Lodestar is more geared specifically towards guiding, the Ultrastar can also be used for live stacking. And they actually give the program to you for free. It was developed by a guy called Paul Shears. He actually developed the programs to allow you to actually do live stacking. So similar to using things like SharpCap. The idea behind it essentially is you put that into the back of your telescope just like you would do with an eyepiece, and it takes 2 shots or 2 frames every second and stacks it together, and you end up with hopefully an image. There's some really good examples all over the internet, and obviously on Starlight Express's website, which is SXCCD. SXCCD.com. You can check out some of the pictures that were taken using the Ultrastar, but its primary function, like the Lodestar X2, is to do guiding. In fact, by definition, it's actually one of the best guide cameras out there in today's market, especially if you are doing off-axis guiding. It's like a recommended must to do something like that, you know, with longer focal lengths, especially if you're like, I don't know, going crazy like a 14-inch SCT or something like that. Next up, we're going to talk about some of the big boys. This is one of their bigger cameras. This particular one is the Trius line. This is the SX814. Oops, upside down, probably back to front. Sorry, cameras, I don't know how to flip this yet. We're working on that stuff, you know, technology. This camera is based off of the Sony sensor. I'm going to try and pull up the information for this particular camera. This one in my hand, I believe, is monochrome, so super sensitive. Now, the great thing about this camera compared to others, so most people will turn around and say, you know what, it's CCD, it's a little dated, it's old-fashioned, or, you know, nobody really cares for any of this kind of stuff. Well, the funny thing here is, though, CCD as a technology still exceeds CMOS by quite a lot. The idea behind this is I'm getting the most amount of performance from a camera that I can possibly get for doing astrophotography. Incidentally, things like quantum efficiency, the well depth, has a huge impact on the type of cameras, on the camera that you use, depending on the actual object that you're shooting. So one good example would be this. When you change the gain settings on, say, like a CMOS camera, the more you increase the gain, the shallower the well becomes. That's basically how it works. With a CCD camera, its reported well depth is actually its true representation. So regardless of what you change your offset or your gamma or your gain to be, the well always remains the same somewhat. And the idea behind that is, if I'm doing a longer exposure for, say, 10 minutes, and people will understand what I'm talking about when you're using a CMOS camera, namely something like the 1600 base chip from Panasonic. What happens here is stars will start to bloat, and the reason for that is the well depth, because of the increase in gain, because you're going to shoot at unity gain, which is 139, will fill up that well way too quickly, even though it claims it does X amount of thousands of electrons. Well, that number just got cut down because I've just increased the gain. So what happens here is that well overflows a lot quicker and then spills out onto the neighboring pixels. And then those end up getting registered, which is why your stars will bloat. CCDs, on the other hand, don't tend to do that. And then on top of that, they have one other functionality called anti-blooming. The idea behind anti-blooming is it also stops that runoff. That's what creates that vertical diffraction spike, if you would want to call it that. That's only really specific for CCD type cameras, not so much CMOS. CMOS, the way the artifact works is that giant halo, the bloated star. You don't get that nice, crisp, circular, star that you want to expect. So you just get a square or a block or a blob. That's the big difference between a CCD versus a CMOS in that particular sense. So the idea here is when you're using something like this, you are basically at its optimal on whatever your scope is using. Now, granted that the cost of something like this is a lot higher, but this is where Starlight Xpress has kind of gone out of its way to create better functionality and usability for today's market. What they have done here is they've added, if you can see it, it's kind of tricky black on black. Oh, there's the light, perfect. As you can see on the back of it, it has the main USB that goes to the computer, then there is a power, then there is a ST4 port, for lack of a better description, and you've got 3 mini USBs here. The idea behind the 3 mini USBs is you can actually plug in the guide camera, their filter wheel, and possibly one other accessory if you have anything else like that. And the whole thing can be powered just off of this unit. Now you'll notice there's actually 2 power plugs. They give you in the bag, or in the box in this case, all the accessories you need to plug everything in. So this, for example, goes in from here to here, and then you just plug the power supply into this. And if you have any 12-volt power supply, it's more than ample to power this thing. It's not like a separate 12-volt, 5-volt system with some other cameras that you might come across. It's all 12-volt across the board. It is a cooled camera, as you can tell. They've opted for a dual cooling system. They've actually got a proprietary piece of technology, for a lack of a better description, that actually helps eliminate, if not all, of the amp glow. If you actually get other counterparts of this camera, there's the SX814, which uses another chipset, and obviously this is the 814. In the 694, you can almost do a 5-minute exposure or even a 10-minute exposure and still not need dark frames, because they've solved a huge issue with what causes this amp glow. And by doing this, they've added this extra fan, and some of the components, you can't really see it, and I do not recommend you dismantling these. So the components where this blows into happens to cool in from that particular side, where this particular piece of patented technology, I'm not really supposed to tell you what it is, but the technology is contained in that little area, and by utilizing the cooling fan, it's able to perform even harder than other cameras based off of this particular CCD sensor. Again, this one's the 814. Now, one other function here is, a lot of people probably don't notice this, but on the front of all these cameras, you'll notice there are 3 screws. Well, these 3 screws are not actually here for fun. They actually serve a purpose. A lot of the times when you have a optical system together, the one thing that you cannot mess with is the focuser. It's very hard to try and get the focuser to be square on. Well, the great thing about this is I can actually change the tilt of this camera to realign with the optical path. If you feel that when the actual camera goes into the scope that it's slightly off centered, I can adjust to recenter that. Now, for those of you who own a CMOS camera, may have come across this. You shoot a flat frame, and you'll notice that the flat frame is more favored to one side. Remember, by design, it's done on purpose in order to avoid Newton rings. Newton rings are these circular things that obviously when two parallel surfaces come in contact together, form what is a phenomenon known as a Newton ring, circular concentric rings that go inwards, and it's very, very difficult to remove. And they tend to be, they tend to happen when you have two flat glass surfaces and you're doing something that you look through them. You'll know what I mean, and when you see Newton rings, you can't really miss them. That's the idea of the offset on those. Well, the great thing here is those CCDs don't, well, this particular one actually, doesn't really have that problem per se, and the way that they eliminate it is they give you the ability to be able to manipulate this so it can go backwards and forwards and so forth and so on, and adjust the tilt. You don't need to go crazy. It's not meant to be for collimation or anything like that. It's just meant to get rid of the tilt or realign the sensor so it's flat against the field. If you notice you have excessive coma on one side of the frame versus the other, and you know that you've got the actual back spacing set correctly at the 55 millimeters, but you notice you've got an excessive mount on the left-hand side or the right, hey, guess what? We can just tilt slightly and correct for some of that so we can recenter that path. So that's a huge feature that this particular camera has over all the others, which, you know, is by today's standards something that is just very, very overlooked by comparison. Now, Starlight Xpress also does multiple other things. They also have filter wheels. Nothing exciting about filter wheels. It's just a wheel with filters that you put into it. But the caveat about this is they have a filter wheel system that has off-axis guiding built into them. So the idea here is you're using something like the Lodestar and the actual filter wheel plus the off-axis guider. It's an all-in-one unit, and they've already worked out what the back spacing should be, so you do not chew up all your back focus. So if you're on a limited back focus of say 55 millimeters with most refractor reducers, you're not chewing this all up using their system. In fact, it actually just comes in around about 42-ish, 42 millimeters when everything's all said and done. For those of you who are relatively new and looking into buying a system, Skywatcher did the 20th anniversary edition of their telescopes, you know, the Spree and the Quadro. And what they did was they partnered with Starlight Xpress, and they picked the two major cameras, including this particular camera, to do their package. The beautiful thing about it is they've worked out everything, the back focus, the spacing, the whole 9 yards, so it's just simply plug and play and off you go. One of the biggest questions that I always get asked is, does this actually work with things like Sharp Cap? Yes, it does, but in a very limited capacity. You have to understand that Sharp Cap is a free piece of software, and CCD cameras in general are a premium. In terms of pricing, from a performance standpoint, people tend to find CCDs very, very expensive. More importantly is you have to understand that when you're using a high-end camera, you kind of don't want to use budget software, because all you're doing is producing or creating yourself a budget result. So the idea behind it is you're supposed to use these cameras with programs like Maxim DL, SkyX, and Sequence Generator Pro. You know, in other words, you're going to spend $3,000-$4,000 on a camera. Don't cut corners on the software. Understandably, the software can, you know, cost you in the hundreds and even thousands, depending on whose software that is that you're using. Personally, I prefer SkyX. Richard Wright very kindly gave me a demo copy just to check out, and I tell you one thing, it's a very, very intuitive piece of software, and it works. In other words, I don't have to mess around too much. I can just plug the camera in, run the drivers, and I am good to go. That's the beautiful thing about, you know, using something like the SkyX and even Maxim DL. Once you install the drivers for the camera, no problem. In fact, any software that has ASCOM compliant or can do ASCOM based cameras, it will work. Sharp Cap to a certain extent works, but again, you've got to understand, Sharp Cap is one of those freemium style software. It's not made to be very high performance, and it was certainly never designed for the higher end CCDs in mind. That's why you would, pick the appropriate software to work with it. Let's see if we can try and open this up for questions. Not a lot of you right now. Who have we got here? Let's be nosy and see who's watching. So if you guys have got any questions out there, feel free to fire them off. All right, I just got the chat window open so I can actually see if there's anything being said. So yeah, if you have any questions regarding the Starlight Xpress cameras, now's your chance. I just went through the differences, or one of the biggest difference between CCD and CMOS cameras. So yeah, anybody got any questions? I know there's 2 of you watching. For all I know, it could just be people in the store. I hope not. I like to think I'm somewhat useful in this planet. No? Can you even hear me? Okay, all right, so let's move on to something else. This is the CoStar. This is what I was just showing you earlier. The CoStar is actually an older camera, believe it or not. Its primary function, or if not, it's pretty much its only real function, is actually guiding. A lot of their smaller guide cameras, like I said before previously, is they actually make the best guide cameras in the market, at least by anybody's definition. So all the different cameras they have, let's just go through the list. Products. So they have the Lodestar, they have the Superstar, the CoStar, and the Ultrastar. The Ultrastar, it doesn't matter if it's the monochrome color one. That one is more of like a general purpose. You can do planetary, and when I say planetary, I'm talking about planetary nebulas like the Ring Nebula, Helix Nebula, etc., etc. That is actually one of the best cameras for that. Now, just be aware that CCDs do not work like CMOS cameras. They are not designed to be fast. Okay, so you can do live stacking, but it's not designed to do like fast live stacking. It has a limited functionality because majority of all CCD cameras are still only using USB 2, and in fact, majority of the time it's actually serial conversion to USB, so they are still relatively slow. But the idea here is they're not designed to be these fast moving, high frame rate cameras where you can catch the International Space Station at 120 frames whistling across the surface of the moon, or whatever the case may be. So these cameras are designed specifically for long exposures. That is their forte, that is their thing. The advantage of using a CCD tends to give you better images. In fact, signal to noise ratio compared to something like a CMOS is actually a lot better. In other words, I get less noise on a CCD than I would do on a CMOS camera. CMOS cameras essentially were created to fulfill a need to introduce people into astronomy. So most of you guys who are watching this probably have one of those QHY-ZWO cameras, or whichever company that you take your fancy to. But what you will tend to find is the people that get published in magazines and get a lot of recognition, they're actually using CCD cameras because they give you the best results. So instead of having all these problems that you can get with CMOS, one of them being the horizontal banding, as it's known as, the 174 suffers from that quite hideously. But again, calibration frames can solve all of that. But the thing here is, though, I'm putting in more work in order to calibrate these errors out. Different camera manufacturers produce different results, even with the same chip. So when you're picking a CCD camera, you need to make sure that they have a good, strong history. And Starlight Xpress has a good history of manufacturing and making CCD cameras. Again, one of the biggest things that they've overcome is they have a specific type of technology. The way they designed everything is to eliminate the need to have to shoot dark frames, because they're able to reduce the amp glow so incredibly well that it's virtually not there. And you can do long exposures, 5 minutes, 10 minutes, and it's still minimal at most. Obviously, because of stacking over time, it does become more and more obvious. But even if you did like a 4-hour total exposure, you don't have to worry about having to do all these calibration frames. And you can of course recycle your calibration frames, you know, there's nothing stopping you. It doesn't get any worse. So that's essentially the big thing when it comes down to using something like that. So looks like we don't have anybody else on the chat. So if you guys do have any questions, don't be afraid to ask, just comment down below, or the side. I don't know which side it's going to be on. It's not up there, that's for sure. So yeah, if you guys got any questions about any of this stuff, feel free to call us. The number is 888-427-8766. You can email us at orderinfo@telescopes.net, or you can put on the comments down below to say how good or bad, or you know, whatever you want to say. It's all good. We take everything in strides. So until next time, hopefully Daniel will be back to do his thing on Wednesday, and then I will be back doing something else, hopefully. Don't forget to check out our other videos on our YouTube channel. We have ones that are like, you know, pre-done, unlike this live environment. And hope to see you again soon.